linear functions in the house tonight. Everybody will cry and laugh, and we'll make you use your mind. Okay, so we're looking at linear functions. So a bit of a recap of stuff that we did from last year. So we learnt the equation of a straight line, and we said that if it's a horizontal line, it will be of the form y equals and then just a number like y equals 3. If it's a vertical line, then it will be of the form x equals a number. And then for any other type of line, then we had two forms. We had the gradient intercept form, which is when you can see the gradient and you can see the y-intercept. And then we had the two-intercept form, which is when you can see where it hits both of the axes. So that would be the root and that would be the y-intercept. So I'll show you what I mean by those. If I've got the line here, if I move this point here to somewhere, say here, then I would work out the gradient by seeing how much do you have to go up and then how much do you have to go across. So you have to go up 3 and you have to go across 6. And so the gradient is 3 over 6, which cancels down to a half. So that's why we just got a half in here. Okay. So, and then the y-intercept is here. It's the plus c, the y-intercept. So if I just restart that and do that with, just rub that out. If I restart that and do that with a point where I've got a y-intercept, say, of 8, so it's hitting the y-axis at 8, then the equation of that line would be, well, the gradient is minus 5 up over 6 across, so minus 5 over 6 is the gradient, and 8 is the y-intercept. So y equals gradient times x plus y-intercept. If I move this so that I can see where the where that is hitting the x-axis, so that's the root, and where that is hitting the y-axis, I can still use the same method as I used before. I can still use y equals mx plus c, but maybe in this case it's easier just to write it not using that method. I could do, and I could write it as y equals, the y-intercept is 8 and the gradient is minus 8 over 10, so minus 8 over 10 x plus 8. And of course you could cancel that minus 8 over 10 down. It would just become minus 4 over 5. Minus 4 over 5. But maybe the easier way of forming the equation in that case is just x over root plus y over y-intercept equals 1. And so if you see an equation written in this form, you can immediately see, it's got to be equal to 1 on the right hand side. You can immediately see what the y-intercept is and what the root is when it's written in that form. Okay, and of course we did mention this, but if you have a horizontal line like this, let's just reset that. If you have a horizontal line like that, then that would just be, very simply, the gradient is 0, so it'd be just y equals 6. And if you have a vertical line like this, say, move that there, you can see that on the x-axis that's hitting at 7. The gradient of this line is sort of infinite, so, or undefined is the gradient of this line, and so we just get a vertical line, which is not in the form y equals, it's on the form x equals. And just generally speaking, if I've got my equation of my line, and let's say that's my equation of my line, so y equals 2/3 x plus 2, then I can, work out the coordinates of any points on the line using my graph. So I know that the point 15 has a y coordinate of 12, and of course I could just do it using the calculator as well, using the equation as well. I could just put in y equals 2/3 and x is going to be 15 plus 2, and 2/3 of 15 is going to be 10, so y equals 10 plus 2, so y equals 12. And of course, working it out, calculating it from the equation is going to give us a better answer than if we read it off from the graph. I mean, in this case it seems quite clear cut, but sometimes it will seem quite clear cut, but it's not actually a whole number. So it looks like 13, but it's not quite 13. That might look like 11, but it's not quite 11. Okay, so starting off with proportional relationships. And so we've got an example. A country wants to change all its speed limits from kilometers an hour to miles per hour. Well, that seems kind of backwards. We should be moving towards SI units, which would be meters per second or kilometers per hour. They know that 8 kilometers per hour equates to 5 miles per hour. Produce a conversion graph with kilometers per hour on the x-axis and miles per hour on the y-axis. And then these two numbers here are in kilometers per hour. So 40 and 55 are in kilometers per hour, but we want to change them into miles per hour. Okay, so this is a proportional relationship. So if your speed is 0 in kilometers per hour, then it will be 0 in miles per hour. So that when one of the measures is 0, the other measure would be 0. The only difference is they increase in a different way. So the kilometers per hour increases much more quickly than the miles per hour does. Okay, so when we draw our graph for this, we know that it's going to go through the origin. So we know it's going to go through the origin. And the other piece of information they tell me, which I'm going to use to get my graph right, is 8 kilometers per hour means 5 miles an hour. So on my x-axis, 8 kilometers per hour. So let's move to 8 on my x-axis. And that equates to 5 on my y-axis. Okay, so there's 8 and 5. And then it's gone through the origin. I've drawn it going through the origin. I haven't given it a y-intercept. And so that equation will just be y equals 5 over 8x plus 0. You don't even need the plus 0 here. It's not necessary because the y-intercept is 0. So we can just call it y equals 5 over 8x. And so if we want to convert other numbers, so they asked us to convert 40. So I'll try and convert 40. I'll try and go to 40 there. Okay, it's not quite going to 40. Okay, there we go. Got it to 40, and that looks like being 25. And that looks quite accurate, but let's just double check it, because remember, graphs are not 100% reliable. So we can do it using algebra instead. So y equals 5 over 8x, and we want to put in x is 40. X is 40. Y equals 5 over 8 times 40. And of course we can cancel that down. 8 goes into that, 4 goes into that twice, and 4 goes into that 10 times, and then once, and then 5. And so that gives us 25. Okay, so that gave us 25. We were quite confident with that anyway. Let's do the other one. It's going to be 55 that they wanted us to convert. 55. Let's see if I can get that on exactly. Oh, no, it's not going exactly. Let's try fiddling with it a bit. It's just not really playing ball. Okay, I got 56 exactly. Okay, I can't get exactly 55. You know what? I'll just use the equation. So y equals 5 over 8 times x. Y equals 5 over 8 times 55. And so that's going to give us 275 over 8, which would be 272. So 34 and 3/8. 34 and 3/8, or 34.375. I don't think I could have read that unaccurately off the graph. Okay, so that would be miles per hour. So we converted 55 kilometers per hour, and it became 34.375 miles per hour. So this is still proportional relationships. So Sahara, the world's largest high street retailer, is having a Black Friday sale. Everything is reduced by 15%. But they don't have time to put new price labels on every item in the store. And they know their customers are a bit thick and the customers don't understand percentages. So they want to create an interactive graph on the touch screens around the store so that customers can use them to help figure out what price they'll have to pay. You've been tasked with the job. I've got a graph set up here, and I know everything is reduced by 15%, and the easiest thing that would be for me to work out is that a £100 article would be reduced by 15%, so 15% of 100 would be £15, so it would be £85. £85. So that's on the label, and that's what you'd actually have to pay at the till because of the 15% discount. So what I'm going to do is I'm going to use that as my starting point. 100 is, I'm not going to be able to fit that on there. 85. 100 is 85. Okay, and of course it goes through 0, 0, because if the article is priced £0, then even with the discount it's still going to be £0. Okay, and so we can get our equation of our line by working out the gradient. And so the gradient is 85 up over 100 across, and so our gradient is going to be 85 over 100. So y, wrong colour. So y equals 85 over 100x, and then of course we can cancel that down. So 5 goes into that 17 and 5 goes that into 20 times. So there's our equation, y equals 17 over 20x. We don't need the plus 0, there is no y-intercept. It's a proportional relationship. Okay, so that was pretty straightforward. Just to complicate your job, they've decided that for items priced £50 and over, the discount will be increased to 25%. So let's say it's not the individual items, it's your bill. Let's not say it's your individual items, it's your bill, your total bill. So if your total bill is £50 and over before the reduction, then the discount will be 25% instead of being 15%. So here's our existing graph that we had, but now what we want to do, and we already worked the equation for that out, but now what we want to do is we want to say, okay, but we're going to increase the discount. So if you're buying something that's £100, you're not going to get it for 85 anymore. You're going to get it for 25% off. So that's going to be £75 you'll pay. So let's move this down to 75 instead. Okay, so there, we've moved that down to £75. And so there's our new graph. But look, this is how the graph goes. So the graph looks like this. It is this equation here. Let's try and use different colors to highlight it. So it's this equation here, which is the equation we had before, which is y equals 17 over 20x. So that was y equals 17 over 20x. But that's only up to x is 50. So that's only x is less than 50. So it's that graph there. But then it changes to this graph here. It changes to this graph here. And it's that graph there, which is just, the line is going to have a gradient of 75 up and 100 across, which is going to be 3/4 x. There we go, we've got that equation there. So this line here is going to be y equals 3/4 x. And this is when x is greater than or equal to 50, is when we're going to apply this equation. And what that means, strangely, and this does happen in real life, is if you're buying something, and let's say it costs £48, so you'll be on this line here. So you'll only get the 15% discount. So the 15% discount means you'll pay £40 50p for that item. So that's the undiscounted cost. And that's how much you'll pay at the till. That's the discounted bill. But let's say you then say, okay, well, no, let's up it. Let's buy something that costs £50. Well, for £50, you would get 25% discount. So you'd only pay £37.50. which is kind of a ridiculous situation, but it happens in real life. A person who walks to the till with £48 worth of goods will pay £40.50. A person who walks to the till with £50 worth of goods will pay £37.50. They'll pay less. So they'll pay £3 less, even though their shopping is £2 more. So the answer is, you know, if your bill is close to £50 but below £50, go and pick up some, you know, cheap items like some chewing gum or something like that to bring the bill over £50, and then you'll actually end up paying less. So this is your first question. This is your first question. So you need to screenshot that. And it's doing a conversion from kilograms to pounds. And it says, a lot of people say you just multiply by 2.2, but actually 2.205 is more accurate. And it wants you to draw a conversion graph, just like we did on the previous pages. And it's told you the scale to use. 10 centimeters is 1 pound on the x-axis, and 5 centimeters is 1 kilogram on the y-axis. And then, you know, draw your line of best fit. Use graph paper. And then, using your graph, do the conversion of 1.5 pounds to kilograms. Obviously, if you just use the scale factor method, it's going to be more accurate. You're going to calculate your answer. It's going to be more accurate. But I want to see what the reading you get is from your graph. I want to see how close you can be reading from your graph without using the calculator. Okay, so those are proportional relationships. They go through the origin, but linear relationships won't necessarily go through the origin. So I'm going on a holiday to America, but I don't understand how they use temperatures, how they use Fahrenheit to measure temperatures. I thought everyone used Celsius. I know that 15 degrees C is 59 degrees Fahrenheit, and I know 25 degrees C is 77 degrees Fahrenheit. And they want me to produce a conversion chart, and then they want me to work out what these would be in centigrade. Okay, so let's have a look. So we're going to do 15 is 59. So we're going to do 15 is 59 and 25 is 77. So I'll just move these points. 15 is 59. Here we go. And the other one was 25 is 77. So let's move that to 25 and 77. Okay. So now what it's going to do is it's going to calculate the line of best fit for me. And it's saying that the line of best fit is 5/9. We went up 10 and we went across 18, and the gradient is up over across, so 10/18, which cancels down to 5/9. And so the equation of this line is, the way we do this is we do y minus y1 equals mx minus x1. And we pick a point. So we pick any point on the graph that we like. So maybe you prefer this point, 77 and 25. So you do y minus, the y coordinate of that point is 25, equals, the gradient is 5/9, 5/9, x minus, and then the x coordinate at that point is 77. Okay, and so that's going to give you, multiplying out, y minus 25 equals 5/9 x minus 77 times 5/9. So that's going to give us 77 times 5 is 385 over 9, and then we just add on the 25 to both sides, add on the 25, and so that's going to give us y equals 5/9x, and then that's going to give us minus 17 7/9, something like that. Okay, so there's our equation. Okay, so there's our equation. So then we can use that equation to work out, to convert 47 degrees into Fahrenheit. So 47, let's try just doing it on here. 47, I don't think I can get exactly 47. Let's see, 40. No, it's not really letting me get exactly 47. I know it's sort of there. So it's going to be about 8.25, but I'm just going to have to calculate it. So I'm going to have to stick that. So y equals 5 over 9. X is going to be 47. 47 minus 160 over 9. So then that's going to give me y equals 5 times 47, so that's going to be 235 over 9 minus 160 over 9. So that's going to give me 75 over 9, which I can cancel down to 25 over 3, which is 8 and a third. 8 and a third. So that's 8 and 1/3. I need to do the other value. Y equals 5 over 9. And then the other value of x that they wanted me to put in was 67. 67 minus 160 over 9. Y equals 5 times 67 is 335 over 9 minus 160 over 9. And that gives me 175 over 9, which would be 19 and 4/9. Okay. So the temperatures when I'm away are going to be between 8 and a third degrees C and 19 and 4/9 degrees C. Okay, so not particularly hot. Maybe take some warm clothes, some, thick puffer jackets and stuff like that. Okay, so we did try and use the graph, but we found using the equation was sort of a better way. So this is your question 2, and it's just like the one we did a second ago. So along the x-axis, you're going to put the diastolic blood pressure, and along the y-axis, you're going to put the systolic blood pressure. And one of the points you're going to use is 40, 40. And the other point you're going to use is 60, 110. And then you're going to connect that with a straight line. And then you're going to tell me the equation of the line. So give the equation. And then you're going to take these two values, they're y values, and you're going to work out the equivalent x values for them. So that's your second question that you need to do. And again, you need to do it on graph paper, but you're going to be using probably a bit of algebra as well. So maybe if you can't read it clearly off your graph. I've changed to a cheaper electricity supplier. My old supplier had a fixed charge of £5 per month plus 50p per unit electricity. So you pay per unit of electricity, but then they have a standing charge or a fixed charge that you have to pay even if you don't use any electricity at all. So let's say you go away for a whole month and you don't use any electricity because you turn everything off in the house, you'll still pay £5 a month if you're with that company, and you'll still pay £10 a month if you're with that company. Okay, so then it says, the new supplier said, for someone with your excessive usage, you'll definitely save money with us. So they're giving a bigger fixed charge, but they're charging less per unit of electricity. So what we're going to do is we're going to plot those onto a grid. So the first supplier charges a fixed charge of £5, and then the gradient of the graph is going to be the cost per unit, because my x-axis here, just move this down a bit, my x-axis here is going to be the units of electricity used. So the gradient of my line, you can see the gradient of my line is 0.5. I've tried to do a little, I've tried to do a little box like that. So you've got a line here. you've got some axes here, and you've got 1, 2, 3, 1, 2, 3, and you've got 1, 2, 3 on this axis, and I know it is 50p per unit. So this is in pounds and this is in units used, and so I know that 1 unit costs 50p, 0.5 pounds. And so my line looks like this, okay? And the gradient of that line here, let's do it in a different color. The gradient of that line is 1 across 0.5 up. So I've tried to draw that there, but it's so tiny you can't see it. So what I've done is I've drawn it a bit larger, and I've said, okay, well, if that's 0.5 and that's 1, if you make that 10, that will be 5, and so it's a bit bigger to see that. Yeah, so 5 over 10 is a half, 50p per unit. Okay, so the standing charge is here. Can you see I've started my y-axis from 4? I should really start it from 0, but sometimes you compress the y-axis, so you just do something like this. You have your x-axis like this, and it goes 1, 2, 3, 4, and your y-axis has a zigzag here, and then it goes up, and so it's starting here at, say, 4. It's not starting at 0 and then 5 and then 6. So you should do a little zigzag if you've compressed the axis. I can't do that on the program, it won't let me do that, but if I was drawing it manually I would draw the little zigzag. Okay, so this is the correct equation and graph for my supplier. It's 50p per unit plus the £5 fixed charge. So when we write the equation in the form y equals mx plus c, this would be the standing charge. It's the number that y would have if x was 0. If x was 0, that would disappear, and that would be the amount that you'd have to pay, and that's why they call it the fixed charge or the standing charge. And then here, the number in here is the gradient. It tells you how much they increase, so how much y increases when x increases by 1. How much you pay per extra unit of electricity. How much your bill increases for each unit of electricity consumed. Okay, so anyway, that's just explaining that equation. Now, the second supplier has got a different charging structure. Their fixed cost isn't £5. Their standing cost isn't £5. Their standing cost is £10. Okay, which on its own would make them always more expensive. More expensive means a higher bill, and you can see this graph, the purple one, is always above the pink one. But actually, their charge is not 50p per unit. Their charge is, I think it was 40p per unit? Was it 40p per unit? Yes, it was. It was 40p per unit. So their equation is different. And what you find is, obviously, if you're not going to use any units, they're going to be more expensive because they've got a fixed charge of £10 as opposed to the other who's only got a fixed charge of £5. But at some point, when you've used a large number of units, so let's say it's at this point here, when you've used a large number of units, and from my graph it looks like 50, I can't be 100% certain about that, but from my graph it looks like 50, then the prices are the same for them both. And then if you're going to use more than 50, then all of a sudden this one doesn't become the cheaper one. So originally this one was the cheaper one. Let's get a pink. Okay, we can't really get a pink, so we'll just go for a red. Okay, so this one is the cheaper one here. That's the cheaper one. But then when you get past here, then it suddenly changes, and this one is the cheaper one. So anybody using less than 50 units should go with supplier A. Anyone using more than 50 units should go with supplier B. But if you're exactly at 50 units, then you could choose either company. They'd be equivalent at that point. But you might have to make an estimate. You might have to say, no, often mine is, it's usually 50, but then it's often less than 50 because maybe I'm out for a week or something like that. So I'll go with this supplier. Or no, it's quite often more than 50 because as soon as it gets cold, I really like to turn the heating up high. So it's often more than 50. So I'm going to go with this supplier. Now, of course, the ideal way to do it would be to use the algebra. So this equation, y equals a half x plus 5 and this equation, y equals 2/5 x plus 10, you just make them equal to each other. See, when would they be equal to each other? When would a half x plus 5 equal 2/5 x plus 10? Okay, so let's minus the 2/5 x from both sides. So that's going to be 5/10 minus 4/10, so it's going to be 1/10 x. And let's minus the 5 from both sides, equals 5. And let's multiply through by 10, x equals 50. Yeah, just what we suspected, it is 50. Okay, so 50 units is the new supplier said for someone with your excessive usage, you'll definitely save money. So you can say that my usage is greater than 50. It's greater than 50. I think it's a lot greater than 50 because they said with your excessive usage. So I think it's a lot greater than 50. Okay. My old supplier has tried to entice me back. This is what they've said. We will reduce our charge to 32p per unit for any units above 70 units. So just to clarify that, my old supplier is offering a fixed charge of £5 per month, then 50 pence per unit for the first 70 units, and then 32 pence per unit after that. And my new supplier that I'm trying to change to is £10 per month plus 40p per unit. So they're still sticking with that. My new supplier has said for my usage, we will still be cheaper. What can you say about my usage now? Let's look at the graph situation again. Now this is the graph situation we had before, which was the old supplier was 0.5x plus 5, and the new supplier was, let's just move that down a bit, and the new supplier was 10 plus 0.4x, so that was the new supplier. But then when we get to 70 units here, which is £40 of bill, 70 units is £40 a bill. When we get above that, our old supplier says they'll reduce the charge. So if I just move this point to there, so that's at 70 units. When I get to 70 units, then they're going to reduce my charge to 32p per unit. So if they'd kept it at 50p per unit, then the line would have just stayed as it used to stay. But they said, no, we're going to reduce it to 32p per unit. So at 32p per unit, their cost per unit goes down. And you can see that at some point here, after that, the dotted line is below the solid line. So my old supplier becomes cheaper again. So in this region here, the new one is cheaper. So in this region here, the new supplier, we'll call that B, is cheaper. B is cheaper. And then in this region here, the old supplier, A, is cheaper. Oh, sorry, I got that wrong, didn't I? The new supplier is this one here. So it was the old supplier that was cheaper. It was A that was cheaper here. And then, because it's the lower line, that one's the line that's below. And here the line that's below is the new supplier. So that's B is cheaper. And then over here, it's the dotted line, which is from the old supplier. So A is cheaper again. So the situation's got more complicated again, because this graph, the equation, this line, is formed of two separate equations. I need to find this second equation. I need to find this equation here. So I'll do that. Y minus y1 equals mx minus x1. So y minus, I'm using the coordinates of this point here, and p I can see is 70 and 40. So y minus y1, which is 40, equals my gradient. My gradient is 32p. 32p. So 0.32, or you can call that 32 over 100, which you can cancel down to 8 over 25. So you can call it 8 over 25. So equals 8 over 25, x minus x1, x minus 70. So we can multiply that out. Y minus 40 equals 8 over 25 x minus 70 times 8 over 25. We can cancel that down. 14 and 5. And so that gives me 112 over 5. Just rewrite that. That gives me 112 over 5. And then now just add 40 to both sides. So y equals 8 over 25x. So we've got minus 112 over 5 plus 200 over 5 is going to give me plus 88 over 5. 88 over 5. And so there's that equation. That's this equation here. That's this equation here. I'll try and write it on there. 8 over 25 x plus y equals 8 over 25 x plus 88 over 5. And this point here is when this line here, and we know that equation, it's that equation here, it's y equals 2/5 x plus 10. It's when this line here meets this line here, which is that equation. So I can just do a little bit of simultaneous equations. I can do 2/5 x plus 10 meets 8 over 25 x plus 88 over 5. And so I can minus the 8 over 25 from both sides. So that will be 10 over 25. So it's going to be 2 over 25 x equals, and then I can minus 10 from both sides. So that's going to be 50 over 5. So that's going to be 38 over 5. And then I can multiply both sides by 25. So 2x is going to be 190. 2x is going to be 190. X is going to be 95. Okay, so x is going to be 95. So this must be 95. This must be 95, and it does look like 95. So it's nice to see that my graph acts as a check. But my new supplier said, for my usage, we will still be cheaper. So my usage, as we suspected, it was a lot more than 70. It's even more than 95. So it's greater than 95. It's greater than 95, maybe 96, maybe 100, maybe 200. We don't know. So this is your third question. So O2 are offering a free iPhone on a 2-year contract for just £80 per month. So the fixed price is 0, and the gradient is going to be £80 per month. So we're going to have a gradient of 80. Okay. You might want to use, because this is going to run into quite a lot of money, so you might want to use a scale like this on your grid. You might want to use x is going to be the months. X is going to be the months. And to use 0, 1, 2, 3. And then y is going to be how much you spent. So this is going to be your cost in pounds. But you might as well do it in hundreds of pounds. So 100, 200, 300. So the 1 stands for £100. Okay, in which case this gradient would be 0.8 because it's 0.800 pounds. So the gradient is 0.8. And this gradient is 0.45. Gradient equals 0.45. Okay, so my line for my iPhone starts from the origin because there's no fixed cost. And then the gradient, which is the cost per month, is 0.8. That's the variable cost, the cost per month. And my friend's one had to pay £480 for the phone, so that's his fixed cost. And then he pays only £45 per month, so draw a gradient of 0.45. He claims his deal is better over 2 years, and he even showed me a graph to prove it. So you're going to have to draw those graphs, and then you're going to have to find where it meets. And it says, he's so uncool, working out stuff like a proper kid. How much more will I pay over the 2 years? So you use the equation of this line, and you say, how much is that going to be total over 2 years? At the end of 2 years, you're out of contract, so you can cancel your contract, so you'll have to stop paying. What length of contract would make my deal attractive, and who actually is the idiot? Okay, well, that last part is kind of not really a question. You'll see the keyword flash up in the screen shortly. Okay, so these are going to be questions that we're going to do in the class. So I went on a comparison site to see if I could save money on my electricity bill. That's very much like the one that we did a second ago. And it's got that same complicated thing where zero fixed charge, 25p per unit for the first 100 unit, for the first 1,000 units, and then 5p per unit after that. So the line is going to change equations after 1,000 units. I'm looking at the best deal on a 12-month rental of a van. Hertz has offered me £50 per month plus a fixed cost of 50p per mile. Six charge £100 fixed cost per month, and they include the first 250 miles for free. After that, they charge £2 per mile. What annual usage would you say to use sixth? Okay, there's a bit of confusion going on here, because they talk about per month and they talk about per mile. And I don't think the per month, I don't think that's the variable cost. I think that's the fixed cost. So I think we should ignore the per month. We should maybe just work out the whole thing based on 1 month. So we should say, forget per month. Let's just say the whole thing is just for 1 month. I only want it for 1 month. Okay. So let's scratch that. Let's scratch that. Let's scratch that. It's all just going to be done for 1 month. And then of course, when we want to work out the annual usage at the end, we can just multiply it by 12 to convert it into an annual usage. This time they've given us the equation of the line, and can you see they've zigzagged this axis, so we don't know where the origin is, but we can still find the equation of the line. And this one, again, we've got the graph already drawn for us, and we need to find the equation of the line. And this one is getting quite complicated. It shows the graph, the water level in the tank varies with time. And it says, draw a graph showing the rate of change of volume in the tank. So we need to be able to work out what the volume is. And this equation gives you h. So this y-axis is h, and this is t. Okay, so it's not actually y, it's h. And that's t. And so we know what h is at different times. So we've got an equation for h. Can we work out an equation for volume in terms of h, and then bung in our equation for h into there? Okay, so it's going to get quite complicated. I think this is a question I'm going to ask you in the lesson to think about and give me answers for. Okay, don't forget to prepare for your test, and I will put up the homework in the lesson, or Mena will put up the homework in the lesson. I will see you in the next homework fix. Mena will see you at the weekend. Bye.